Hello guys. So many of you have requested me to solve some of the problems on few methods that I have missed in my numerical methods playlist, and so today I am going to do one of those, and the topic that I am going to do today is the Gauss Jordan method. Now, Gauss Jordan method and Gauss elimination method both are almost same. The difference is in Gauss elimination method we had to form an upper triangular matrix, okay, from the augmented matrix, and after that what we used to do is we used to back substitute and get the values of our variables. But here we will not do the back substitution, rather we will get our values directly. Okay, so now let's see how it is done by solving an example. Now the example here goes like 2x plus 3y minus z equals to 5, 4x plus 4y minus 3z equals to 3, 2x minus 3y plus 2z equals to 2. So this is our system of linear equations, and what we have to do, we have to form an equation like this: ax equals to b, okay, where a will be the matrix of the coefficients of the variables, x will be our variables, and b will be our constants. Okay, so let's form this one. So a will be our matrix of the coefficients, so 2 3 minus 1, then we have 4 4 minus 3, and the last equation we have 2 minus 3 and 2. X here is x y z, and the constants here is 5 3 and 2. So this is our ax equals to b. Now what we will do, we will form the augmented matrix. Okay, so our augmented matrix here is 2 4 2 3 4 minus 3 minus 1 minus 3 2, and here 5 3 2. So this is our augmented matrix. Now what we will do, we will perform row transformations on this augmented matrix, and finally we will get the values of our variables. So let's start that. So what I will do is, since there is no space left, I will just rub this part. I will write the augmented matrix and perform the row transformations on it. Okay. So our augmented matrix was 2 4 2 3 4 minus 3 minus 1 minus 3 2, and the constants were 5 3 and 2. Okay, so this is our augmented matrix. Now the first row transformation that we will apply here is on row 2, and the transformation will be row 2 minus 2 row 1. So let me write it first. So row 2 will be equal to row 2 minus 2 row 1. Okay, so let's do the transformation. So our row 1 is 2 3 minus 1 5, and our row 2 will be row 2 minus 2r1, that is 4 minus 4, that is 0, 4 minus 6, that is minus 2, minus 3 plus 2, that is minus 1 again, sorry, minus 3, and 3 minus 10, that is minus 7. Okay, sorry, this will be minus 1. Okay, So this is our first row transformation. Now we can apply another row transformation here, and that will be row 3 can be changed to row 3 minus row 1. Okay, so let's do that. So row 3 minus row 1, that will be, this will be 0, minus 3 that will be minus 6, and 2 plus 1, that will be 3. Okay, and here 2 minus 5, that will be minus 2, sorry, minus 3. Okay, so this is our first row transformation. Now the second one. After that, what we can do is we can apply row transformation on row 3, and that can be row 3 minus 3 row 2. So let's write first. So row 3 can be row 3 minus 3 row 2. Okay, so now let's perform it. Now row 3 is 0 minus 6 3 minus 3, and row 2 is 0 minus 2 minus 1 minus 7. So row 3 minus 3 row 2, this will be 0. Okay, then this one will be minus 6 plus 6, that will be again 0. Then we have 3 plus 3, that is 6. Then we have minus 3 plus 21, that is 18. Okay, now row 2 will be as it is, that is 0 minus 2 minus 1 minus 7. Row 1 will also be the same, that is 2, 3, minus 1 and 5. Now next operation that we can do here is, since in the last row we have 6 and 18, therefore we can divide it by 6. So our next operation or row transformation will be row 3 will be row 3 by 6. So let's do it. 2, 3, minus 1, 5, 0, minus 2, minus 1, minus 7, 0, 0, 1, 3. Okay, so what we have got is, we have got this part 0. Okay, so now what we can do is, we can get the value of our z very easily without back substitution. Now we have to do the same for x and y also. So the next operation that we can do is, row 3 can be modified into row 1 plus row 3. Okay, so let's see. So row 3 can be row 1 plus row 3, right? Now that will be equal to sorry, this is row 1. Row 1 can be row 1 plus row 3. So this will be 2, this will be 3, this will be 0, and this one will be 8. Okay, now the next operation that we can do is row 2. Row 2 can be written as row 2 plus row 3. So this will be 0, this will be minus 2, okay, minus 2, minus 1 plus 1, 0, minus 7 plus 3, that will be minus 4, and row 3 will be as it is. Okay, now the next operation that we can do is on row 2. Since both of them are multiples of 2 and minus 2, so we can write row 2 will be equal to row 2 divided by minus 2, and the answer will be 2, 3, 0, 8, 0, 1, 0, 2, 0, 0, 1, 3. Okay, so what's left? Left is only this part. We have to make this 0. Rest, our job is done. Okay, so now for this we have to apply one last transformation, and that will be row 1 will be equal to row 1 minus 3 row 2. Since here we have 1, therefore we will write row 1 minus 3 row 2. Here is 0, here is 0, so this will not change, only this will change. Okay, So our transformation will be 2 0 0 8. No, this will not be 8, this will be 2 0 1 0 2 0 0 1 3. Okay, so our transformation is complete. We have got this one as 0 and this one as 0. Only we have the diagonal elements. So what will be our result? Now our result will be, let's write it properly. So I hope you all have followed this one. Okay, so now I have to rub it off. So the final matrix that we got was 2. The final matrix that we got was 2 0 0 1 1 0 0 0 0. Okay, and we had the constants. I will write the constants separately. So 2 2 3, and here we have the x y z. Now from this we can calculate the values very easily. How? Let's see. So 2x will be equal to 2, that means x will be equal to 1, y will be equal to 2, and z will be equal to 3. Now how I got this, I hope you already understood. I just operated matrix multiplication here. Okay, so this row multiplied by this row, this one by this one by this, and we got the result here. So the final result will be x equals to 1, y equals to 2, and z equals to 3. Okay, so this was the Gauss Jordan method. In Gauss elimination method, we only performed the operations, row transformations, and we had to find out the upper triangular matrix. Okay, but here what we did, we performed the row transformations, okay, and just let the diagonal elements remain, and we eliminated all the other elements in the matrix so that we can calculate the values very easily. Okay, so what is the difference between Gauss elimination and Gauss Jordan is, here our time is saved a little bit because we have not to do not perform the back substitution method to calculate the values. So this was all about the Gauss Jordan method. Tomorrow I will be again live at 10 p.m. sharp with the second method. Thank you.